All right, good afternoon. How is everyone today? Doing great, glad to hear it. All right, so let's start off with any questions or issues so far. I haven't had a chance to look at the PA-A's, but I'm assuming that worked out for everybody. Button looks almost identical to the chat button. And is where the chat button normally is. I don't think I have a Q&A button either. Yeah, well, I'm on Linux, so my version of Zoom is always like, you know, a few years behind what's on Windows and phones. Well, what happens if you click the Q&A button? Maybe we'll get answers or questions. Click it, man. No open questions. Ah, interesting. Okay, so yeah, presumably there's a way to ask questions, but I don't seem to have that option. Yeah, Pirate Bay Zoom, right? All right, cool. Any other questions, issues? We were playing with the string class yesterday, and that was a good example of, you know, a class with some methods, and you know, we played around with the length method and the character at method and so on. What I want to do today is start writing our own class and use that to get a better handle on this idea of what goes into a class, and the different pieces of it and so on and so forth. So let's make a class. All right, so let's pop up a window. And I gotta make my conversation box pop up. All right, let's see. We did triangles this morning. Let's do rectangles today. I'm gonna make a rectangle class, and so it's gonna have to be in a file called rectangle. And this is a good point to mention some conventions. And so here's a pretty standardized naming convention when you're working with Java. When you're creating a class, the class name is usually uppercased. Okay, so first of all, Java usually uses camel case, right? So instead of putting underscores in between, you know, words of a variable or just jamming them all together, we do camel case. So if you wanted to have, you know, this is a really long variable. Well, that's really hard to read, right? So in languages like Fortran, right, once you were able to do variables with more than one letter in the name, and you didn't want to jam them all together like this, you would usually do underscores. This is really long variable. And that's, a lot easier to read than this. And that's what's called snake case. Java and, C, Python, most other languages like this, where uppercase, lowercase are different from each other, we usually do something called camel case. So this is a really long variable. All right? And it's still, a lot easier to read than this, but it saves our underscore key, and it doesn't look quite as goofy. So, but regardless of how you're casing this, if you're doing a class, it's generally going to start with an uppercase letter. But if you're defining a variable, the variable name itself, which is an object, is usually going to start with a lowercase letter. And if we were snake casing it, we might do my rectangle to make that a little easier to read. But the first letter is significant, right? Now, it makes no difference to Java. It makes no difference to the compiler, to the JVM, but it's almost completely standardized. Classes start with an uppercase. Objects, right, instances of classes start with a lowercase. So you want to have that habit, and what you do in the privacy of your own home is totally up to you. But if you're coding with other people, or on a team or things like that, or probably for assignments and other classes, you want to try to stick to what's sort of best practice at the time. Yeah, sure enough, you have a Q&A button between participants and chat. Interesting. I'll have to try that on my Windows machine. Let's see if I can get that. All right, and so that's snake versus camel case. All right, so let's go ahead and make a rectangle class. And so if we have a rectangle, right, what do we have? Well, we basically have a length and we have a width. So let's just define these. And we can get away with just this. This is a perfectly fine class. Right? We've defined a new type of variable called rectangle, and it has two components to it, a length and a width. And they're both integers. And we can use this kind of like we use structures in C, right? It's functionally the same. Let's write some code to use this class. So I'm just going to call this main. Terrible choice of a name, but that's okay. So I'm going to make a class called main, and I'm going to put my main program in here. All right, this is boilerplate, right? The name of the class that we're defining, main, that's because I'm in a file called main.java. If I was in PA1, this would have to be class PA1, and so on. But let's write some code in here, and so let's make a rectangle. So R1's a rectangle. Well, what does it mean to be a rectangle? It means you have a length and you have a width. So we can start playing with these. So we can say something like R1 length equals 10. R1 dot... Did I really call it length and width? Let's call it height. All right, length and height. So the length will be 10 and R1 dot height will be 5. Yeah, so inside VI you can say :VI and get to another file. So I'm inside main, so I get into rect.java. I don't know :E. Oh, that's interesting. Because that message you just said the message you just sent said it was from you to all panelists instead of to everyone. So you're definitely in some kind of interesting mode right now in Zoom. Yeah. So we're having a panel discussion. All right. So I'm doing all kinds of strange things here. So I called my rectangle class .class instead of .java. That was a typo. All right. So you want your files to be .javas. All right. So here's my main .java. And yeah, from inside here I can say vi rectangle.java and switch over to that. And then the nice thing is, once you've done that, if you do control and a 6 or control and a caret, you can switch back and forth between those two files. And you know, you can yank from one and paste it in the other, and so on and so forth. So, but there's lots of things you can do. Yeah, just remember :vi file. And remember control 6, and just play with those once in a while. They're actually pretty convenient when you're doing development, just for going between two files. Oh, interesting. All right, so control E may do something very, very similar to that. All right, so here's our main class. We have a rectangle named R1, and we're setting its length and its height to be 10 and 5 respectively. And the rectangle class is just kind of like a structure statement right now. Okay, so let's go ahead and compile this. And it looks good, but we're going to get some errors here. All right, and the error we're getting is at line 5 of our main program, variable R1 might not have been initialized. And we're saying R1.length equals 10. Okay, so think about what this is saying. It's saying R1 might not have been initialized. Well, we're initializing, this is down at line 5, we're initializing R1.length. That's perfectly fine. But R1 itself, it's complaining, might not have been initialized. So let's go back to C for a minute and think about structures. And think about, you know, something like a struct node root. Okay, that's a declaration of this variable named root. That's what's happening up here. We're declaring a variable, technically an object, R1, to be of type rectangle. And now imagine that in C you said something like root arrow data equals 15. What's most likely to happen when I execute that statement in C? Seg fault, right? We get a seg fault because even though I've said root is a pointer to a struct node, I haven't initialized root. I haven't made it point to an actual struct node yet. In fact, root is probably null, and here I'm trying to dereference null, and that's going to give me a seg fault. So we need to do something in here like root equals, we need to give it a value, and typically we do that with malloc, or, you know, maybe we'd copy some other pointer to a valid struct node and set root equal to that, and so on. And so that's basically what's happening with our rectangle. We've said R1 is a rectangle, but it's not actually pointing to any particular rectangle. All we've done is kind of set things up, right? So we need to make R1 actually point to a rectangle. And so instead of malloc, the keyword we use in Java is new. So we can say R1 equals new rectangle, and that will create an instance of a rectangle. Okay, so that's creating or instantiating a rectangle. And so R1 is an object. And so new rectangle, new is a keyword that basically says, do what you have to do to create one of these things, an object of this type. So an object is created from a class, exactly. It's exactly the way to think about it. Cool. Alright, so VI, when in EX mode, leave EX mode, go back to normal mode, otherwise same as edit. Okay, cool. Got it. Alright, so now R1 is going to be an instance of a rectangle. How do you have multiple windows up? So I'm on my native Linux laptop right now, and anytime I open a terminal window, it pops up in a new window, and so I can have as many of these as I want, and move them around and resize them and so on and so forth. And yeah, you can do this inside VI also. You can do a split screen inside VI, and you can use other terminal windows like Tilex that let you create split screens both horizontally and vertically and move around from them and so on and so forth. And most terminal windows are tabbed also, so I can have 2 tabs and I can keyboard shortcut from one to the other. And there's all kinds of things, right? So this is the kind of stuff that I'm thinking of in 224 when I'm talking about exploring your environment and finding something that works for you, right? Doesn't really matter to anybody except you how you do this stuff, but find a setup that works well for you, right? If you like, having different desktops where you can just move around from one to another, that works great. If you like having multiple windows, if you want different tabs, or whatever else. I use Vim Windows to avoid having multiple SSH sessions. That's cool. Yeah. Yeah, definitely come by office hours, anybody who's interested in this, and we can actually set up different options for you. And it's totally worth spending time on this, because you're probably going to be doing, command line development for a number of years after this. And you're going to be working in Linux for a number of years. And so it's definitely worth getting a nice environment that works well for you. All right, so we've created an instance of a rectangle. So let's go ahead and compile this again. That should compile just fine. And if we run it, it doesn't do anything. We didn't ask it to do anything. But it compiles and runs perfectly fine. All right, let's see. Yeah. Excellent. All right. Yeah, cool. All right, so let's take a look at what's happened now that we've done this. If I look in my directory, I actually have 4 files in here, right? I have my 2 Java files, my main program, my rectangle class. But when I compiled main, I got my main.class, that's the bytecode, the binary version of main.java. But it also knew that it needed to use the rectangle class, and it found the source code in this directory, so it went ahead and compiled that. Right? So we can go pretty far with Java without really needing to worry about things like makefiles. To some degree, it kind of works. It kind of does that for you, right? Compiling things when it needs to compile them, and so on and so forth. But not always. All right, so let's make this do something. Let's play with our new rectangle. All right, I'm make this a little wider. So let's print out the area of R1. So I'll just make a print message. The area of R1 is, and I'm just going to print out length times height. And let me do this a little more. Let me do it like this so we don't get into weird stuff. If bytecode is binary, what is it? Why does it look how it does? Well, just because it's binary doesn't mean that we can't read some of it, right? Just like if someone is speaking Spanish, I can still understand some of it even though I don't actually speak Spanish. So there's things in here that, you know, are best represented in plain old readable ASCII like this. But it's a binary file in the sense that it's meant to be ingested by, you know, a program rather than ingested directly by the programmer. If that makes sense. And no, I'm not suggesting that Spanish is binary code. Will it look in subdirectories for relevant files too? So there's a whole class path that will be searched when it's looking for a class to execute, and you can modify that, and you can change it to look in other areas. I don't think it automatically looks in subdirectories of your current dir, but it will look in other things. So I'm compiling this by just saying javac main.java. And that'll compile main. It'll also compile rectangle. If I just wanted to compile rectangle, I could just compile rectangle.java. And if you look in your directory, if you have the .class files, then they probably just got compiled. If you don't have the .class files, they're not getting compiled. All right, so we've added a print statement which will print out the area of R1 is. And remember, the plus sign is concatenation, so we're concatenating the answer, which is an integer, which should be the area of the rectangle. So let's go ahead and run main. And oh, I gotta save this first. Right, and so the area of R1 is 50, which is good because it's a 5 by 10 rectangle. Looks like it doesn't recognize rect at the moment. Make sure it's in your current directory. Make sure it's an uppercase R. Make sure it's a .java file extension, and make sure you're compiling it with javac space and then the whole file name. And if any of those are different, and make sure the class inside the rectangle.java file is rectangle with an uppercase R, and make sure it starts with the keyword class and so on. All right. So far so good, right? So far this is just like a glorified structure in C. It's a new type of variable called a rect that holds some fields. They're both integers, and we can make, you know, an instance of this class, and we can access the fields like this, and we can access the fields like that. Okay, but this is not quite, you know, an object in the way that we usually think of objects in an object-oriented language. So let's add some more interesting methods. So we're often going to want the area of a rectangle, right? And if we're very clever, we know that we can find the length and the height of the rectangle like this, and we can multiply them using an asterisk, and that will give us the area. But, you know, when we do something over and over and over again, we usually want to make a function for it. And so let's make a function for finding the area of a rectangle. And let me remind you what we would probably do in C, and this is not what we're going to do in Java. In C, we would make something like, you know, integer area, which takes an argument which is a rectangle R, and we'd return R dot length times R dot height. Alright, that's what we do in C, and we can do something like that in Java. But it's getting away from this idea that, you know, the area function really only wants to be called with an argument that's a rectangle, right? We don't want to find the area of an integer or a string. We want to find the area of a rectangle. Spacing does not matter in that context. So just like these fields, length and height, belong as part of the rectangle class, really this area function, which we're going to call a method in Java, this area method really should be part of the rectangle class also, because we only intend it to be used on a rectangle. So we're actually going to write that area method as part of the rectangle class. Okay, so this is our first sort of big twist in the road, where we're changing from how we do things in C to how we do things in an object-oriented language. So let's make a method function for returning the area of a rectangle. So I'm going to use the keyword public to let the system know that it's okay for things outside of this file to access this method. Okay, so it's something that I intend to be called from another piece of the system. So we're going to make it public. It's going to return an integer. It's going to be called area. Okay, so we're kind of, you know, integer area. But we're not going to pass any arguments to it. I'm going to define it like this. All right. So why are we not passing an argument to it? Because I'm going to run this method as part of a rectangle. So here's what I'm going to do. I'm going to say, instead of this, I'm going to say the area of R1. I'm going to say R1.area. Okay, so instead of, and I don't need this anymore, instead of saying area parentheses R1, I'm saying, you know, R1's a rectangle, it's got fields, it's got integer values that I can get to like this, it's also got a function named area. I'm going to get to it exactly the same way, R1 dot, and the name of the function, area paren paren. All right, so that's kind of our first big twist. Okay, we're going to access this function as part of this object, R1.area. And we don't have to pass it R1 as an argument. Why? Because it's being, I mean, we're calling a function that's part of R1. Right? So inside the code for area, we can just do this. Okay, so return length times height. What length? This length. What height? This height. Well, where do those come from? Well, since we're calling R1.area, length is actually R1.length, and height is actually R1.height. And so this is going to return R1.length times R1.height. That's the area of R1. All right, so I want you to really think about that. This is like the big branching off point from non-object oriented to object oriented. right? So when we say blah dot area, length times height means blah dot length times blah dot height. All right, so if we do that, we can compile this. We can run it, and the area of R1 is 50. So probably best to put the word public in here. There's default permissions associated. There's public, private, package, and so on. But I should have put the word public in here. So it was able to access it anyway because there's defaults. But let's put the word public in to be explicit. Actually, you were asking about the rectangle class. So let's put it in there. Right? And by the way, if I were to change this to private, what's going to happen? Right? Well, I can't make a private class. Oh, that's interesting. I guess that makes sense because there'd be no point in having a class that can't be accessed. Length and height are implicitly, I think they're package visible. And since all this stuff is in the default package. But let's be totally clear about this. Let's make these public too. All right. Now if I make one of these private, now we're going to get something very different. Right? My main program, I'm trying to access the height of R1, and it's telling me height has private access inside rectangle. All right, so we want that to be public. These are used not so much for security reasons as for helping to avoid silly issues. I mean, it could be security related, but I don't know if that kind of security exists in a Java virtual machine. But yeah, basically, some data you just don't want to access from outside of the class, right? So think about your stack implementation, right? Let's say we're going to make a stack, and we're going to make a stack using an array and an integer called a stack pointer, and we're going to write some methods called push and pop that a main program can call to add things or remove things from the stack, right? Well, technically, you know, there's no reason why the main program couldn't do something like, you know, look at the value of SP, or increment SP, or change SP to 0. But we may not want that to happen, right? If we're writing the code to implement a stack, we may only want outside entities to access that stack through the push and the pop methods. So this was this abstract data type notion we were working on in 222. And it gets into the idea of information hiding, right, and what's called encapsulation. And so we could say, yeah, you can push, you can pop, you know, use these two methods, but don't touch our stack pointer. Don't touch our array that we're using to implement our stack. Because maybe we're doing something strange in there, you know. Maybe we're incrementing the stack pointer when we push. Well, next week, maybe we're decrementing the stack pointer when we push. And if outside code is manipulating the stack pointer directly, that code might break, right? Because now we're doing something different. So it's a way to sort of take the parts that we're exposing to the world and make those available, and take the parts that are internal and keep those from being accessed and interacted with outside of our package. So yeah, default private unless necessary, right? I mean, it's not quite like a global, but it's a little bit the same feeling, right? If you have lots of things inside your rectangle class that are accessible, it's almost an invitation to errors and mistakes. All right, so let's keep developing this. We've got an area method here. So what can we do with this? Let's go back to our main program. let's make a new rectangle R2 and give it a length and a height of 5. And let's print out its area. And here all we got to do is print out R2.area. But I have to construct it. Alright, so I run that, and the area of R2 is 25. You found your bracket. Awesome. Or your missing bracket. Alright, let's do something else strange. Let's come up with a way to multiply rectangles. So if I have a 2 by 2 rectangle and I'm going to multiply this by a 4 by 3 rectangle, I'm going to define multiplication to mean I should end up with an 8 by 6 rectangle. Alright, so let's do some interactions between these objects. So 2 by 2 times 4 by 3, okay? The way we're going to define multiplication of rectangles, we're going to get a new rectangle whose length is the product of the lengths and whose height is the product of the heights. Okay? Goofy thing to do, but it's just, you know, for the sake of having some code to write. So let's make a new rectangle. And we want to make this the product of rectangles 1 and 2. So again, in C, we might do something like multiply R1, comma R2. But that's ignoring the fact that multiply should be part of the rectangle class, right? This is not a way to multiply anything other than rectangles. So we really want to make multiply part of this rectangle class. And when we do that, here's how we're going to multiply rectangles. We're going to say something like R1.mult R2. And so this is the next big conceptual leap, right? Just like we access the area method of R2 by saying R2.area, we're going to access the multiply method of R1 by saying R1.multiply. And this is going to be a method that takes one argument, which is a rectangle, and multiplies, in this case, R1 by that rectangle. And then returns a new rectangle, which in this case we're going to set R3 equal to that new rectangle. And then we're going to go ahead and we're going to print out the value of R3. We're just going to print out its area. And it should end up being the area of R1 and R2 multiplied together if you do the math. All right. Now I don't need to do a new statement here, right? Because R3 is going to be set equal to a rectangle which the multiply method is going to return. All right. So let's make a multiply method. So this is going to be public. Wow. Okay. It's going to return an object of type rectangle. It's going to be called multiply, and it's going to take a single argument, which is a rectangle. And I don't know, I'll just call the argument R. And so how are we going to do this? We're going to do something like this. Rectangle result equals new rectangle. Result.length equals, well, what do we want to multiply here? in this case, we would want to multiply R1's length by R2's length. And then R1's height times R2's height. Okay, so what's the length of R1? We get to that just with length. Right? That's the length of the object from which we made this call to this method multiply. And we want to multiply that by the length of the argument we passed in, which in this case was R, so R dot length. And then we're going to set the height accordingly. And then we're just going to return that rectangle. And there's our multiply method. So R1 was 50, 20 by 10. R2 was a 5 by 5. R3 should end up being a 50 by 25, I think. But anyway, its area turns out to be 1,250. There we go. Can you explain? You mean these lines of code right here? Yeah. So this is the guts of it, right? And take a look at how we're calling multiply, right? We're saying R1 dot multiply R2. Okay, so the argument we're passing is R2, and it's pretty traditional, right, that, you know, whatever we name our argument here, R, in this case, R would be the same as what we're calling R2 here, right? So that's just plain old, you know, C programming, Python, whatever. That's just, you know, we're passing in an R2, we're calling it R here, so R dot length is going to be the length of, in this case, R2. And the height of R2, well, that's going to be what R dot height gives us. The weirder part, though, is this thing right here, height, and this thing right here, length. Right? And where do those come from? Well, you know, R1 is a rectangle, and we're saying, you know, we're not after R1's length or height, we're after R1's multiply method. Right? We're calling this method as part of R1, which means when we're inside the multiply method and we're running, we're kind of in some sense inside R1. And so if we just say length, it means R1's length. If we say height, it means R1's height. Yep, the length and height are from R1 in this case. If I had done R2 dot mult, then the length and height would be from R2. So that takes some thinking about. But if you can get your brain somewhat around this, you are past one of the big hurdles in getting into object-oriented programming, right? This right here, if you can start to make peace with this, right, you're in a really good spot on the road to object-oriented methodology. So spend some time with this, struggle with this, make some changes to it, get it running, modify it, ask questions about it, right, before you go on to other things. Syntax for creating an array of objects. Yeah, that's a whole nother story, and that would take us really far afield. We'll get to that in a few weeks, actually. And we do not need to free memory in Java. So Java has something called a garbage collector, which runs around and looks for lost memory and reclaims it, right? So we don't have to do frees ourselves. We can, but we usually don't. So if I lose a reference to an object, that memory will get reclaimed eventually. Quick question on terminal: how do you copy paste? Come by office hours and we'll set it up, because it really depends how it's set up. And there's so many options. So for me, I copy by selecting. I paste with Control-Shift-V. But it really depends on the terminal program. All right. Let's see. Let's do one more thing. Let's print out our rectangle. So I'm just going to say system out print line R1 equals, and I'm going to concatenate R1 to it. Now if I concatenate an integer, it just prints out that integer next to the string that I concatenated it to. If I concatenate a rectangle, right, R1 is a rectangle, to a string like, R1 equals, it'll compile, it'll run, but it won't give us a whole lot of happiness. It'll tell me R1 equals, and it, gave us the word rectangle, an @ sign, and then some kind of hexadecimal address. And that's the best it can do. It doesn't know that this is a rectangle, right? So it's telling us the name of the class from which this object was constructed, and then an @ sign, and this is some kind of internal pointer that tells it, where to find this particular rectangle. But we can actually have this do something more interesting for us. Nope, no object overloading for the most part. All right, so we can make a special method. We can construct a special method that will tell the system how to, if we try to concatenate a rectangle to a string, how to do that. How to turn this rectangle into a string. So we do this as follows. We make a public method. We call it toString. We don't pass any arguments. And my toString method is just going to return the fixed string a rectangle. You got to tell it returns a string. So now when I run this, it says R1 is a rectangle. Right? All I'm doing is concatenating R1 to the string R1 equals, but the way that it does this concatenation, first R1 has to be turned into a string. And by default, it does that by using the name of the class, an @ sign, and a crazy hex number. Well, now I'm overriding that behavior, and I'm saying, hey, when you try to turn a rectangle into a string, just use the string a rectangle. And so now anytime I print a rectangle, it's going to print out the words a rectangle. So R1 is a rectangle, R2, R3. Okay, it doesn't take a lot to make this more useful. So let's print out a string like this. So if you asked me to convert this rectangle to a string, I'm going to return the string followed by the length of the rectangle, followed by a times symbol, followed by the height of the rectangle, followed by the word rectangle. Okay, I've changed one line of code. And now when I run this, it tells me R1 is a 10 by 5, R2 is a 5 by 5, R3 is a 50 by 25. And this is something we will do a lot. And basically any object that you try to print, any object that you try to treat as a string, for example, when you try to concatenate it to a string with that plus sign, the system will look for a method called toString. And there's always a default toString which returns something like this. But you can write your own version of this, which is what we've done here. And now anytime that I try to treat a rectangle as a string, it basically gets changed into a string that looks, like a reasonable representation of the rectangle. All right, so we've done a lot of stuff here, right? Three or four main concepts, but basically all the pieces that you're going to need to do PA1, right? And PA1 is really kind of like, the movement to a full-blown object-oriented program. Yeah, I'm going to post this on the Linux server right after class. So take this code and mess around with it. Come by office hours if you want to try getting some of this running and it's not working for you, or you want to mess with your terminal settings or anything like that. But mess around with this stuff, right? Start getting your hands dirty. Hit those walls, right? Get to those points where it's not making sense, and let's push through those. Okay, and once you're on the other side of this, then it's a beautiful sun-swept landscape of green fields and all that sort of stuff. So it's good stuff coming. All right, cool. Have a great afternoon. I will see you next time.